There are several studies in quantum mechanics that relate to prime numbers. One example is the distribution of prime numbers in the energy levels of atoms. Quantum mechanics predicts that the energy levels of atoms are quantized, meaning they can only take on certain discrete values. The distribution of these energy levels is related to the behavior of prime numbers, specifically the distribution of prime numbers in arithmetic progressions. This phenomenon is known as quantum chaos or quantum ergodicity. Another example is the use of prime numbers in quantum cryptography, which is a method of secure communication based on the principles of quantum mechanics. In particular, the security of some quantum cryptography protocols is based on the difficulty of factoring large composite numbers into their prime factors. Prime numbers are numbers that are divisible only by one and themselves, and they have fascinated mathematicians for centuries due to their seemingly random distribution. In recent years, scientists have begun to investigate the distribution of prime numbers in the universe, and they have found some intriguing patterns. The distribution of prime numbers also has implications for the behavior of physical systems. For example, the distribution of prime numbers in the universe might explain why certain physical phenomena exhibit periodicity. This is because the distribution of prime numbers is related to the distribution of the roots of unity, which are the solutions to the equation x raised to the n equals 1, where n is an integer. These roots of unity exhibit periodic behavior, and this behavior might be related to the periodicity of physical phenomena. Moving on to the use of prime numbers in quantum mechanics, there are several examples of how prime numbers are used in this field. One example is the use of prime numbers in quantum cryptography, which is a method of secure communication based on the principles of quantum mechanics. In particular, the security of some quantum cryptography protocols is based on the difficulty of factoring large composite numbers into their prime factors. Moving on to the use of prime numbers in quantum mechanics, there are several examples of how prime numbers are used in this field. Quantum cryptography is a method of secure communication based on the principles of quantum mechanics. In particular, the security of some quantum cryptography protocols is based on the difficulty of factoring large composite numbers into their prime factors. This is because if someone can factor a large composite number, they can break the encryption used to secure the communication. By using prime numbers as the building blocks of the encryption, it becomes much more difficult for an eavesdropper to break the encryption. Another example is the use of prime numbers in quantum computing, which is a field that seeks to develop computers that use the principles of quantum mechanics to perform certain calculations much faster than classical computers. Prime numbers are used in some quantum algorithms, such as Shor's algorithm, which is a quantum algorithm for factoring large composite numbers into their prime factors. This algorithm takes advantage of the periodic behavior of the distribution of prime numbers in arithmetic progressions to break down the factoring problem into smaller subproblems that can be solved efficiently on a quantum computer. Finally, let us consider the potential implications of a prime number universe. One implication is that the universe might be inherently mathematical in nature. This idea is not new, as many scientists and philosophers have argued that mathematics is the language of the universe. However, if the universe is based on prime numbers, it would provide strong support for this idea, as prime numbers are the building blocks of all other numbers and are considered to be the most fundamental mathematical objects. Another implication is that the universe might be more predictable than we currently think. If the distribution of prime numbers in the universe is related to the periodicity of physical phenomena, it might be possible to predict certain aspects of the universe by analyzing the distribution of prime numbers. This could lead to new insights into the behavior of physical systems and the laws of physics. For example, it might be possible to predict the behavior of subatomic particles or the properties of black holes based on the distribution of prime numbers. On the other hand, a prime number universe could also imply that the universe is inherently chaotic and unpredictable. This is because the distribution of prime numbers is notoriously difficult to predict, and even simple patterns can be hard to discern. If the universe is based on prime numbers, it might be impossible to predict certain aspects of the universe with any degree of accuracy. In addition, the idea of a prime number universe raises interesting questions about the relationship between mathematics and physics. Mathematics and physics are often thought of as separate disciplines, but if the universe is based on prime numbers, it would suggest that the two are intimately connected. This could lead to new insights into the nature of mathematics and its relationship to the physical world. It is important to note, however, that the idea of a prime number universe is highly speculative and has not been rigorously tested. While there are some intriguing patterns in the distribution of prime numbers in the universe, it is not clear whether these patterns are meaningful or simply coincidental. Furthermore, the relationship between prime numbers and the behavior of physical systems is not well understood, and it is unclear whether the distribution of prime numbers has any direct impact on the behavior of the universe. In conclusion, the idea of a prime number universe is a fascinating topic that raises many interesting questions about the nature of the universe and the relationship between mathematics and physics. While there are some intriguing patterns in the distribution of prime numbers in the universe, it is important to approach this idea with a healthy dose of skepticism and recognize that much more research is needed before any firm conclusions can be drawn. Nonetheless, the study of prime numbers and their relationship to the universe is an exciting area of research that could lead to new insights into the fundamental nature of reality.